Okay, let's dive right in. We're all constantly hearing about these massive, all-powerful AI models that live way up in the cloud. But today, we're going to explore something different, a totally radical blueprint for an AI that's personal, that's private, and that runs right on your own laptop. Now, to really get why this is so important, we have to start with a huge problem. You see, the current AI models, they're basically designed to drink from the internet's fire hose. They just consume everything, and that leads to data bloat, some really serious privacy risks, and frankly, a ton of repetitive noise. So what if the key to a smarter AI isn't more data, but just better data? All right, so here's our game plan. We'll kick things off with a problem, then introduce this radical solution called ES-LM. We'll pop the hood to see how it works, check out its security, and then see why this whole new approach could put a seriously powerful personal AI on pretty much every laptop out there. Think about it. Right now, when you use a typical AI, your questions, your data, it's all getting sent off to some giant black box model in the cloud. And these models are constantly feeding on the entire web, mixing up high-quality gems with total junk. This makes it a real challenge to get a clear, trustworthy signal, all while your privacy is, up in the air. But what if, and this is a big what if, an AI could actually get smarter by using less data? I know it sounds crazy, but that is the absolute core idea behind the EfficientSearch LLM, or ES-LLM for short. It's built on a completely different philosophy, and it all starts with one simple but incredibly powerful rule. This one, number 10. This is the key to the whole thing. The entire ES-LLM concept is built on this hard limit. For any question you ask it, it's only allowed to look at the top 10 search results. That's it. It's so clever because it's piggybacking on the amazing ranking algorithms of search engines, which means it's already starting with a high-quality, super relevant slice of the internet. No endless crawling, just a laser focus on the best stuff out there. And this table just lays out the difference so perfectly. On one side, you have traditional AI trying to know everything by swallowing the whole internet on massive cloud servers. But on the other, ES-LM runs right on your laptop, and its only goal is to find and stitch together the unique signals from that tiny, curated slice of the web. It's not trying to be a giant knowledge database. It's your own personal intelligence filter. So this brings us to what they call the signal-first philosophy. Instead of just grabbing more and more data, the system is obsessed with quality and uniqueness. It's like a gold miner, aggressively hunting for the signal, those core facts and new ideas, while tossing out all the noise. The repetitive SEO fluff, the marketing jargon, and the same explanation rephrased 20 different ways. Okay, so how does it actually do this? How does it take those 10 potentially repetitive search results and pull out only the unique, valuable bits? Well, let's pop the hood and take a look inside the unique parse engine that makes this whole thing possible. It all happens in this really slick 5-step pipeline. First, it grabs those top 10 results. Then, it converts everything, text, images, even video, into a common language the machine understands. But here's where the magic really happens. Step 3, deduplication. It cleverly finds and merges every single overlapping fact. What's left is this clean knowledge map of only unique information. The AI only reads this final, clean map to give you an answer. And believe me, this deduplication is incredibly effective. By comparing information not just by the exact words, but by its actual meaning, the system can slash the amount of data the model needs to process by up to 60%. It instantly sees that 5 different websites are just rephrasing the exact same fact and merges them into one. All right, but wait a minute. If you're pulling information from the live internet, how can you possibly be sure it's secure and private? This is where the system is designed like an absolute fortress. So let's explore the layers of privacy that actually make it trustworthy. This quote from the source material just nails it. The goal here is something called data sovereignty, and what that really means is you have absolute, total control. All the learning, all the data processing, all your questions, they stay right there on your device, period. Nothing ever leaks back to the cloud. And the design has this almost military-grade security posture. Web content gets fetched in what's called an air-gapped sandbox, so it's completely walled off from your personal files. The entire software stack is built on audited, USA-vetted open-source projects. Plus, it automatically scrubs personal info out of the search results it finds. It is truly security by design, from top to bottom. So, a system this powerful and secure must require a monster of a computer to run, right? Actually, no. The entire concept is designed to be democratic, efficient, and accessible enough to run on a totally standard laptop. I mean, just look at these minimum specs. An older Intel i3 processor and just 8 gigs of RAM is enough to get going. This is only possible because that signal-first approach means the model processes way, way less data, and it uses these super efficient small language models that are optimized to run on the hardware you probably already own. And the user interface is built completely around transparency and control. You can literally watch the AI build its knowledge map in real time. You can click on any statement in its answer and see exactly which of the top 10 sources back that claim up. And with a simple toggle switch, you decide if the model learns from you. You are always in the driver's seat. And for all you builders and developers out there, this system also offers a simple, secure API for other apps to connect to it. This means other tools on your laptop can tap into its power, turning your device into this central personal intelligence hub, and it's all done privately and efficiently. So, let's zoom out. What does this all add up to? Yeah, a faster, more private AI is great, but the implications here are so much bigger than that. Let's bring it all together. The benefits really flow directly from the design. It's faster because it processes less data. It's private because it runs locally on your machine. It's efficient enough for older hardware. It puts you in total control of its learning. And by focusing only on high-signal information from top-ranked sources, it delivers more accurate, concise answers. And this brings us to one final, really provocative thought. This ES-LLM blueprint, it points toward a future of data sovereignty. It asks us to imagine what becomes possible when powerful AI is no longer a centralized service you just rent from some giant corporation, but instead it's a personal, private tool that you truly own and control, an expert that learns from you, works for you, and runs completely on your terms.
Quick build out of the solution for the ES-LLM. If you've been following that thread, you saw that came up with a idea just to see if I could do it and build out a localized LLM running on a CPU without GPUs, and just see if we can't have it run somewhat efficiently on a CPU and provide the information that we need. So I'm going to quickly share my screen that you guys can see. So as you can see, I got it up and running here. But before I do that, I'm just going to quickly go over to my anti-gravity project and show you some of the things that we went through and built. So I had spec'd out a solution where the user comes in, they can either use a combination of a web interface or APIs to interact with a search engine. And then that search engine comes back to the user with results from the search engine, up to 10 search results for the specific topic that you're querying or looking into. It then takes the results of that search result. I'm sorry, it actually runs that search result in two different ways, right? If you're running a Docker desktop instance, it creates a kind of a secure search, and then it gets rid of that container instance. Or if you don't have a Docker instance running for your container, then it'll do a restricted Python wrapper for your search. That's just to make sure that nobody can inject anything into the search engine results. It then will run that through a deduplication of the results. So if you get 5 websites and they're all, 2 of them are saying all the same things basically, or very close to the same things, that gets pulled out of the search results. It'll then create a map, right, of the search results and the content, and then runs that result. And actually, it didn't put it in here, but I also have some NLP summarizer features or function where I'm going to summarize the results of of what comes back from the search engine, and then runs that through the large language model. And I'm running FLAN T5 large locally, and brings those results back, right? And then I also have a feedback database where I am, as a user, can provide feedback to the LLM so that it can, get better and learn from previous queries. So with that said, I'm just going to quickly show my screen here. And as you can see, it created a nice interface for me. And it'll show me some things like the speed, the tokens that were used for a specific search. It knows that I'm running local flan T5. The other thing that is interesting here is, initially I was there's a whole bunch, you can do a whole bunch of local LLMs, but this whole process, I haven't tested them out to see which one works better. But right now, working with just this, Google open source, all of the libraries that are being used here are kind of secured, been checked out, fully maintained within the open source library. This is that toggle that allows you to validate. And then here, a little toggle that will allow you to go back and pick the number of sources that you wanted to check. And it actually increased it to up to 15, but the more sources, the longer it'll take for it to bring back the response. So I'm just going to do this real quickly. Let's just try this. How do I become a day trader? Oops. And we'll see, it'll go out, it'll search it, it'll initialize that secure connection. It's going to start to search for that. It'll come back. These are the 5 different areas it looked into. This is creating the summarization. I used the NLTK to do the summarization. And now the LLM is taking this information. It's going to run through and create an AI-based response from that information. And sometimes it will take a little longer than others. But what you'll also get as a part of the feedback from this is you'll get the feedback of how many tokens it took, and the latency to get the response back. And I had been running at around 20 seconds per response, give or take. I don't know if maybe right now it's going a little bit slower because of just my network speed or whatever's happening. Or I'm sorry, my CPU, because I'm recording this. But I'll give it a second here. There we go, came back. So it took a little bit over a minute to do this. Told me the number of tokens. I can see capital design a strategy. So it kind of gives you a little bit of a response of the information. When I click on the data map here, that goes back to this, so I can see this. So if I actually click between this, it'll toggle between the AI synthetic and the response, and I can say comprehensive steps. And in this time, instead of, let's make it 2. Let's see if it comes back with anything a little quicker. And it's going to still go back and try to figure out those steps. So while that runs, I'm going to come back and we can check it out. It's going to find out. Okay, and this actually just, I think at the end of the day, sometimes it's still a little bit sloppy in terms of context, but it's just giving me comprehensive plan steps. So this is not correct. I'll have to go back and fix this. But at the end of the day, we'll get this connected to the previous conversation. Since the second response came back incorrect, that means that there's some context issues. Now with AI and LLMs, there's a cache that is kept for the context of the conversation, but with a local running LLM, that is reduced significantly. So what I end up doing is incorporating the previous question as a part of the next question if there isn't the right context of the standalone question, trying to kind of mimic that memory, right? That cache memory that is being released because there's a limited number of tokens that the local LLM has. And so what I'm doing here is I'm just writing kind of a result. I took a screenshot of how it did that. And I just said, hey, listen, when it reviewed that question where it said, what are the steps? There was those steps, that wasn't enough context for it to understand what I was actually asking. And so therefore it should have looked at the previous question. So I'm going to see if it tries to fix that for us right now. So again, I'm just plain English feeding that into the agent to see if it understands based on looking at the screenshot of the error as well as looking at my error message to see if it can go ahead and find a solution for me. So it'll work through that. It may take a little bit of time. It's going to try to create a solution or a plan or say, okay, listen, I'm going to adjust the code a little bit. And once it does that, it'll come back and should have fixed that issue for me. There you go. So it's going through right now. Try to fix its solution. OS awareness engine is now more conservative. If you ask a complete question, okay, so it's going through and it's going to do that, but I wanted to update that because it clearly was not working and did not understand my question. So it's going to go back and see my error and try to fix that. And we'll make an adjustment to that POS context engine, or we're calling it context engine. All right, excellent. But you can kind of see here I'm running a localized LLM, and this is coming a little bit faster here, but I was getting, like I said, around 20 seconds for the response from a local running LLM on a CPU. All right. Hope you guys enjoyed the video and look forward to continuing to work on this project. Thank you.